Look up into a clear night sky with your naked eye, and what planets would you see? Technically, you would be able to see all of them at one time or another, all of them, apart from Neptune. It is the smallest of the gas giants and also the furthest away. And it is a perplexing place. You would think a planet so far from the sun wouldn't have a dynamic atmosphere that exhibits ginormous storms and super-fast winds. And yet it does. So, why is this planet as interesting as it is? And today we're going to delve into everything you could want to know about Neptune. History. Let's start right at the beginning. Neptune is the only planet found through mathematical prediction. You see, when Uranus was discovered and astronomers were plotting its orbit, they noticed that Uranus wasn't following their models. From the perturbed orbit of Uranus, Urbain Le Verrier in 1846 concluded that there must be another undiscovered planet, and he predicted where it should be. And remarkably, Johann Galle was able to find it only a degree away from the predicted point. Triton, Neptune's biggest moon, was discovered a few days later. But since then, Neptune has been poorly understood as its distance from Earth and very small apparent size meant it couldn't be studied from ground-based telescopes very easily. It wasn't until 1989 when Voyager 2 arrived that huge amounts of information about the planet became available. Suddenly, we could see what the planet looked like, confirmed it had planetary rings, and discovered a lot of previously unknown moons. But let's get to today. What do we know about this planet now? Since Pluto's demotion to not a planet status, Neptune is the 8th and furthest planet from the Sun. It orbits at about $30 from the Sun on average, which means it's 30 times further than the Earth's orbit from the Sunday $30. In other words, is 4.5 billion kilometers, and from that, you can see why it would take a space probe, using current technology, 13 years to reach Neptune. 4.5 billion kilometers is a considerable distance. Because of this long orbit, it takes a huge 165 years to orbit the Sun once, which means we've only seen one Neptunian year since its discovery. This distance from the Sun means the average temperature in Neptune's atmosphere is very cold, minus 201 degrees Celsius. Its axial tilt is 28 degrees, meaning it's similar to Earth and Mars, which are 23 degrees and 25 degrees respectively. This means it has seasons similar to Earth and Mars too, the big difference being these 4 seasons last 40 Earth years each. At this moment in time, the southern hemisphere is experiencing spring. During this spring, the southern hemisphere receives more sunlight and appears brighter. This increase in brightness is actually quite noticeable, which is strange, as you would have thought that because the Sun is 900 times dimmer on Neptune than on Earth, from that distance it wouldn't make much of an impact. But even if it is only a small impact, it makes an impact nonetheless, and the increased sunlight levels in the southern hemisphere warm it up by about 10 degrees Celsius compared to the rest of the planet. This comparably higher temperature releases frozen methane gas into the stratosphere, causing its increased brightness, whereas elsewhere on the planet it remains frozen and stays deeper in the troposphere. Just a recap of the spheres of a planet. The troposphere is the lowest atmospheric level, followed by the stratosphere. Above those layers are the mesosphere, the thermosphere, and then the exosphere. But that's a very interesting topic in itself, and we'll save it for another video. Weather. If you look at the weather on Neptune, it actually has the fastest wind speed of any planet, with wind speeds blowing westward on the equator reaching a staggering 2,160 kilometers per hour, nearly a supersonic flow. And interestingly, most wind travels retrograde to the rotation of the planet. Bands are also formed on the planet, as well as colossal storms. When Voyager 2 passed by the planet in 1989, it saw the Great Dark Spot, a storm about the size of Earth passing through its atmosphere. Voyager also saw the smaller storm called the Small Dark Spot, south of its bigger sibling. As Voyager 2 approached Neptune, this smaller storm changed in shade from dark to light. When Hubble was launched, astronomers were curious to see the fate of these storms, to see if they were a permanent feature like Jupiter's Great Red Spot. But when Hubble was pointed at Neptune in 1999, these storms had completely disappeared, and storms have come and gone ever since. Giant, bright, high-altitude clouds also come and go. But why then doesn't Uranus, which is very similar in composition and size to Neptune, also have such a blustery atmosphere? Don't get me wrong, wind speeds on Uranus are fast too, but it doesn't compete with Neptune at only 900 kilometers per hour. Can all this only be due to interactions with the Sun and its seasons? Something else must be at play here to explain the extremes in weather. The answer may lie deep beneath Neptune's surface. Inside Neptune, I mentioned that Neptune is the furthest planet from the Sun, so you would have thought it's also the coldest. But actually, Uranus is the coldest planet in our solar system. Neptune radiates heat from within, whereas Uranus radiates hardly any excess heat at all. This could be because a large Earth-sized body crashed into Uranus billions of years ago, which depleted all of its primordial heat. Astronomers now theorize that the more active weather on Neptune might be due, in part, to this higher internal heat. What is Neptune actually made of then? Its internal structure and atmosphere are thought to be very similar to Uranus. Its atmosphere is composed mainly of 80% hydrogen and then 19% helium, with very small amounts of methane. It's this methane, though, that gives Neptune its blue color, although it's a dark shade of blue compared to Uranus cyan. Again, like Uranus, there's a liquid mantle of water, ammonia, and methane ices surrounding the core. And where the core and the mantle meet, the pressure is so great that the methane may break apart, and diamonds are formed under pressure. Likely not diamonds as you or I know, but there could be a liquid carbon ocean with solid diamondbergs floating in it and diamonds raining down through the mantle like hailstones. This is just a theory, though, as technology has only recently started to recreate such pressures. Around the core of Neptune, it's thought to be 7 bar, or 700 GPa, which is about 7 million times the pressure of Earth's atmosphere at the surface. Even the two ice giants' magnetospheres share similarities. Neptune's magnetic field is offset 47 degrees relative to its rotational axis. When Voyager 2 discovered this about Uranus, the first theory was that it had something to do with its unusual axial tilt, but then it found the same thing out about Neptune, which is a more normal axial tilt. So, the current theory is a magnetic field is either not generated in the core but rather by an electrically conducting liquid mantle, that the mantle deflects a magnetic field from the core, which gives it this weird offset in relation to its rotational axis. Every planet in the solar system hasn't actually got a perfectly aligned magnetic field. Even Earth's magnetic north is different from where the North Pole actually is. But it's only Uranus and Neptune that have such a tilted magnetosphere. Aurorae do exist on Neptune too. Neptune's ring system, but they are different to what you might expect as they are extremely faint due to particles not getting as charge from the Sun, and because of the direction of the magnetosphere. They are mainly type B aurora, or SA. Another difference with SAR arcs of Neptune is they are not only found around the poles, but rather are around the mid-latitudes of the planet. Zooming out from Neptune a bit, we come to its ring system. Like all the other gas giants, Neptune does have a ring system, although it is very faint as it is not as dense and is extremely dark in color. If you have these rings against the black backdrop of space and also happen to be this far away from the Sun, then they are very hard to see. But there are 5 known rings in all, and they are named after people involved in the discovery and research of Neptune. The innermost is a Gao ring, which is very faint and very wide at 2,000 kilometers. Next is the first bright ring, Leveria. Although it's bright, it is only 113 kilometers wide. Next and connected is a Larsell ring, a very faint band 4,000 kilometers across. On the edge of this ring is the Arago ring. It is slightly brighter than the Larsell ring, and less than 100 kilometers wide. Lastly is the outermost and the most researched ring, the Adams ring. It is only 35 kilometers wide, but it's one of the brightest rings. It is particularly interesting as it is slightly inclined, and it has bright arcs in it. These arcs have been quite stable since they were first observed in 1980, but usually planetary rings are uniform throughout. These arcs must be material clumping and clustering up within the ring, but the reason for this is currently unknown. Lastly, I want to talk about the moons. Neptune has 14 known moons, which are named after water deities in Greek mythology. The most famous and the largest by far is the moon Triton, which actually contains most of the mass of all of Neptune's moons put together. I personally think it is one of the prettiest moons in our solar system, as it has amazing patterns and this burnt orange color. What is most interesting about Triton is the fact it orbits in retrograde and also at an inclination to Neptune's rotation, which implies it is probably a captured object and not something that was formed alongside the planet. Triton might be the cause of the rings of Neptune, as it would have disrupted the orbits of moons, possibly causing them to collide and break up into what is now the rubble of the rings. Triton is even bigger than Pluto and also has a tenuous atmosphere. Voyager 2 even saw faint clouds on its flyby of the moon. The next biggest moon is Proteus, which is a little irregular in its shape. Normally, we only see this on smaller objects like asteroids, but Proteus is actually bigger at 400 kilometers across than the spherical moon of Saturn, Mimas. Why it is not a sphere is explained by past collisions of things hitting the moon, leaving these massive craters which you see. The inner, regular moons orbit around the rings, some acting as shepherd moons. The outer, irregular moons are all likely captured moons. Some of the irregular moons orbit prograde, and others retrograde. The outermost moons of Neptune are Samoth and Niso, and are the furthest out satellites of any planet that we know of to date. They take a massive 25 years to orbit Neptune only once. This is because Neptune has a very large Hill sphere, the Hill sphere being the sphere in which the planet's gravity overcomes the gravity of the Sun. It has such a large Hill sphere because it's already so far from the Sun. The Sun's gravity has less of an influence around Neptune than at the biggest planet, Jupiter. Well, thank you for watching. Did you learn something interesting about Neptune today? What mysteries about it would you like to see solved? We're still working our way through the planets in our solar system remastering. What planet would you like to see us do next? Let me know in the comment below, and I'll see you next time. Space is filled with some wonderful sights, and